Hello, and welcome to Sleep Archive. We look up at the night sky and we see a scattering of light. We see the familiar constellations, the wandering planets, and the bright, steady glow of the nearby stars. But if we could look deeper, past the foreground of our own neighborhood, we would see that the universe is not a random scattering of dots. It is an archipelago. It is a vast, dark ocean dotted with glowing islands of immense proportion. These are the galaxies. They are the cities of the cosmos, massive congregations of stars, gas, and dust, bound together by the invisible grip of gravity. They are the structures that define the shape of the universe, turning the void into a tapestry of light. Tonight, we will leave the Earth behind. We will rise above the plane of the Milky Way to look down upon our own home from the outside. We will witness the majestic slow-motion rotation of the great spirals and the silent, gravitational dance of the galactic collisions. We will trace the invisible threads of dark matter that weave these islands together into a cosmic web, a structure so large that the human mind can barely comprehend its existence. We are about to explore the architecture of eternity. For most of human history, the universe and the Milky Way were considered to be the same thing. When astronomers looked through their telescopes in the 18th and 19th centuries, they saw a vast field of stars surrounding us. They saw the band of the Milky Way arching overhead, a river of white mist that they understood to be the collected light of millions of distant suns. They believed that this disk of stars was the entirety of creation. Beyond the edge of the disk, there was only the infinite, empty void. They did see strange, fuzzy smudges of light in their telescopes, which they called nebulae, but they assumed these were just small clouds of gas floating within our own system, nascent stars forming nearby. It was a comforting, contained view of reality. We lived in a single, solitary island of light. But in the 1920s, this cozy picture was shattered. The astronomer Edwin Hubble trained the largest telescope in the world, the Hooke telescope at Mount Wilson, on one of these fuzzy smudges known as the Andromeda Nebula. He was looking for a specific type of star, a Cepheid variable which acts as a cosmic lighthouse, pulsing with a regular beat that allows us to measure distance. When he found one inside the nebula and calculated the math, the result was impossible. The star was not inside the Milky Way. It was not even close. It was millions of light years away. In that single moment, the universe exploded in size. Humanity realized that the nebula was not a cloud of gas at all. It was another Milky Way. It was a distinct, separate galaxy, containing billions of its own stars, separated from us by an ocean of nothingness so wide that the human mind recoils from it. We suddenly understood that our galaxy is just one of many. We are living on one island in a limitless archipelago. To understand what a galaxy truly is, we must try to visualize the scale. Imagine our sun, a ball of fire 1,000,000 times the size of Earth. Now, imagine 1,000,000,000 suns. Now, imagine 100 billion suns. A galaxy is a gravitationally bound swarm of anywhere from 100 million to 100 trillion stars. If you were to shrink the sun down to the size of a grain of sand, the Milky Way galaxy would be the size of the entire United States. And in this model, the next nearest grain of sand, the next star, would be 4 miles away. This reveals the defining feature of a galaxy. It is mostly empty space. Even inside these crowded cities of light, the stars are incredibly lonely, separated by light years of vacuum. Yet gravity binds them together. It acts as the invisible wall of the city, keeping the stars from drifting away into the intergalactic void. From the outside, a galaxy looks like a solid object, a luminous swirling cloud. But from the inside, it is a diffuse fog of energy and matter. It is an ecosystem. It recycles matter, birthing new stars from the ashes of the old, circulating gas and dust through its spiral arms like blood flowing through veins. It is an entity that lives, breathes, and evolves over timescales that make the life of a star look like the blink of an eye. As we drift away from Earth, pulling back to view our own home from a cosmic distance, we begin to see the structure emerge. We are not in a shapeless blob. We are in a disk. We are living in one of the most beautiful architectural forms in nature. We are about to see the grand design. As we float in the silence of intergalactic space, looking down at the Milky Way, we are struck by its geometry. It is not a sphere like a star or a planet. It is a disk. It looks remarkably like a frisbee or 2 fried eggs glued back to back. It is incredibly wide, spanning 100,000 light years from end to end. But it is also shockingly thin. If the Milky Way were the size of a pizza, the disk itself would be thinner than the crust. This flattened shape is not an accident. It is the inevitable result of physics acting on a massive scale. When the galaxy began, it was a giant, shapeless cloud of hydrogen gas, collapsing under its own gravity. But this cloud had a tiny random rotation, a slight spin. As gravity pulled the cloud inward, shrinking it down, that spin accelerated, just like a figure skater pulling in her arms. The centrifugal force of this spinning motion fought against gravity, preventing the gas from collapsing toward the center along the equator, but doing nothing to stop it from collapsing from the top and bottom. So, the cloud flattened out. It spun itself into a pancake, creating the galactic plane that we see today. This is the thin disk, and it is the engine room of the galaxy. It is the home of the gas, the dust, and the nebulae. It is where the star formation happens. When we look at the disk, we see that it shines with a brilliant, piercing blue light. This color tells a story. Blue stars are massive, hot, and extremely short-lived. They burn through their fuel in a few million years and die. Seeing a lot of blue light means that these stars were born recently, essentially yesterday in cosmic time. The disk is a nursery, constantly churning out new suns from the dense clouds of gas that settle in the plane. But as we move our eyes toward the center of the galaxy, the color changes. The blue fades away, replaced by a warm, yellow-orange glow. We are looking at the galactic bulge. Rising up from the center of the disk like the yolk of the egg, the bulge is a dense, spherical swarm of stars. Here, the architecture is different. The stars are not moving in a neat, orderly circle like the traffic in the disk. They are chaotic, buzzing around the center in random, 3D orbits like bees around a hive. And they are old. The yellow light comes from ancient, smaller stars that have been burning for billions of years. There is very little gas left in the bulge. The star-making factory shut down here long ago. It is a relic of the early universe, a dense concentration of the galaxy's first citizens. But the galaxy does not end at the edge of the visible light. Surrounding the entire structure, the disk and the bulge, is a vast, invisible sphere known as the galactic halo. It is a ghost town. It contains very few stars and almost no gas. It is a region of darkness that extends far beyond the luminous boundaries of the spiral arms. Yet, it is here that we find the oldest objects in the universe, silent sentinels that have been watching the galaxy spin for 12 billion years. This tripartite structure, the flat blue disk, the round yellow bulge, and the dark, vast halo, is the standard design for the heavyweights of the cosmos. But there is a detail in the disk that captures the imagination more than any other. The disk is not a smooth sheet of light. It is carved into beautiful, curving arms that wind out from the center like a pinwheel. These are the spiral arms. They look solid, like the blades of a fan. We intuitively assume that they must be rigid structures, groups of stars that are permanently locked together, spinning around the core. But if that were true, the galaxy would have destroyed itself long ago. If the inner stars orbited faster than the outer stars, the arms would have wound up tighter and tighter until they disappeared, like winding a string around a spool. But the arms persist. They have lasted for billions of years, maintaining their perfect shape. This presents us with a puzzle. How can a structure made of disconnected, free-floating stars keep its shape while spinning? The answer reveals that the spiral arms are not what they appear to be. They are not things. They are events. We transition now from the static map to the dynamic flow. We are about to enter the traffic jam. The spiral arms of a galaxy are the most distinct features in the night sky. They define the shape of the Milky Way, winding out from the center in a perfect, logarithmic curve. But they are also an optical illusion. If you were to look at a spiral arm and think of it as a solid branch of a tree or a rigid spoke of a wheel, you would be wrong. The stars inside the arm are not permanently attached to it, they are merely passing through. To understand this, we must look at the physics of a traffic jam. Imagine a busy highway. Traffic is flowing smoothly until a repair truck slows down in the middle lane. The cars behind the truck are forced to brake, bunching up together. A cluster of density forms a knot of cars. But the cars do not stay there. They slowly move through the knot, past the truck, and then accelerate back to full speed on the open road ahead. From a helicopter, the traffic jam looks like a permanent, stationary object on the highway. But if you look at the individual drivers, the membership of the jam is constantly changing. New cars are entering the back, and old cars are leaving the front. The structure is a wave of density, moving independently of the cars themselves. This is exactly what a spiral arm is. It is a density wave, a ripple of gravitational compression that sweeps around the galaxy like the hand of a clock, but moving much slower than the stars themselves. The stars in the galaxy are the cars. They orbit the center at high speeds. As they approach a spiral arm, they feel the gravitational pull of the density wave in front of them. It acts like a speed bump. The stars slow down and pile up, crowding together in the arm for millions of years. Eventually, their momentum carries them through. They exit the front of the arm, accelerating back into the empty space between the spirals until they hit the next arm, and the process repeats. Our own sun is currently located in a minor spur called the Orion Arm, but it has passed through every major arm in the galaxy over its long life. We are currently stuck in traffic, drifting through a region of high density. But this theory explains more than just the shape, it explains the light. Why are the spiral arms so bright? Why are they traced in the brilliant blue ink of young stars, while the space between them is dark? The answer lies in the gas. The galaxy is filled with giant, invisible clouds of hydrogen gas. When a star hits the density wave of an arm, it just slows down. But when a gas cloud hits the wave, it crashes. The compression is violent. The cloud is squeezed by the gravity of the traffic jam, collapsing in on itself. The pressure spikes, the temperature rises, and suddenly ignition. The traffic jam acts as a shock wave that triggers the birth of new stars. The spiral arms are not just structures, they are factories. They are lighting up with the blue glow of millions of newborn stars, created by the squeeze of the wave. This is why the arms stand out so vividly. The massive blue stars are born in the arm, shine brightly for a few million years, and then die before they have a chance to leave the traffic jam. They are like flares that are lit only in the tunnel. The smaller, yellow stars like our sun survive the journey. They drift out of the arm and into the quiet darkness of the interarm regions, carrying the memory of their violent birth with them. So, when we look at a galaxy, we are seeing a self-sustaining pattern. The wave creates the stars, and the gravity of the stars sustains the wave. It is a perpetual motion machine of light and gravity, a grand design that requires no architect, only the laws of physics. But as we trace these arms inward, following the curve of the traffic jam back to the source, we arrive at a place where the laws of physics begin to warp. We are heading for the exact geometric center of the galaxy. Here, the stars are not leisurely drifting through a density wave. They are screaming around a central point at impossible speeds, whipped by a gravitational force so intense that it bends light itself. There is something in the middle, something dark, something heavy. We are about to meet the monster. We leave the graceful, sweeping arms of the disk and dive into the chaotic heart of the Milky Way. We are entering the galactic bulge. The environment here is radically different from the quiet suburbs of the solar system. The stars are packed together tightly, separated by light weeks rather than light years. The night sky here would be blindingly bright, filled with thousands of stars shining with the intensity of the full moon. But as we push through this dense swarm, moving toward the absolute center, we notice something terrifying. The stars are moving too fast. In the suburbs, stars drift leisurely at 200 kilometers per second. Here, deep in the core, they are whipping around at speeds of 5,000 kilometers per second. They are screaming through space, completing orbits in mere years rather than eons. They are dancing around a single, invisible point in the dark. For decades, astronomers watched these stars, specifically a star named S2, trace a perfect, tight ellipse around nothing. It was as if they were orbiting a ghost. But gravity does not lie. By calculating the speed of these stars, we weighed the ghost. We found an object with the mass of 4 million suns, crushed into a space smaller than the orbit of Mercury. There is only one thing in the universe that can be this heavy and this small. We are staring at Sagittarius A star. It is a supermassive black hole. It is the gravitational anchor of our entire galaxy, a singularity where space and time are knotted into an infinite dead end. Every major galaxy in the universe has one of these monsters lurking in its basement. And monster is the right word. If you were to fall into it, you would cross the event horizon, the point of no return, and simply vanish from the causal history of the universe. But contrary to popular belief, this black hole is not a vacuum cleaner. It is not frantically sucking up the galaxy. Sagittarius A star is currently on a diet. It is a quiescent black hole, a sleeping giant that has long since eaten the gas and dust that once surrounded it. It sits quietly in the dark, with only the occasional asteroid or gas cloud falling in to create a brief flare of X-rays. But it wasn't always this way. Billions of years ago, when the galaxy was young, this beast was feasting. It was a quasar, a blindingly bright engine of destruction that outshone the rest of the galaxy combined, blasting jets of radiation thousands of light years into space. There is a deep, mysterious connection between the hole and the host. The size of the black hole is always perfectly proportional to the size of the galactic bulge surrounding it. They grew up together. The galaxy fed the black hole, and the black hole with its violent outbursts of energy sculpted the galaxy, blowing away excess gas and stopping the formation of too many stars. They are a binary system of creation and destruction, locked in a feedback loop that determines the fate of the island universe. But while the center is dominated by this dark, heavy tyrant, the outer edges of the galaxy are guarded by a different kind of relic. We turn our gaze away from the crushing gravity of the core and look outward toward the lonely, high-altitude regions above the galactic disk. There, floating in the halo like ancient satellites, are spherical cities of light that date back to the very dawn of time. We are about to visit the halo of ancients. We fly upwards, leaving the spinning disk and the dark monster far below us. We enter the galactic halo, the vast, empty sphere that surrounds the Milky Way. Here, in the cold silence of the outskirts, we find the globular clusters. They are the most beautiful objects in the night sky. Imagine a ball of light, perfectly spherical, packed with 1,000,000 stars. They look like diamonds resting on black velvet, or swarms of fireflies trapped in a glass jar. But these are not just pretty lights, they are fossils. These clusters are the oldest structures in the universe, the first things to form when the galaxy was still just a collapsing cloud of gas. They date back 12 or 13 billion years to a time before the Earth, before the Sun, and before the spiral arms even existed. While the disk below is a place of constant change where stars are born, live, and die in a cycle of recycling, the globular clusters are frozen in time. They have no gas left. They stopped making stars eons ago. Every star inside them is a red giant or a white dwarf, an ancient, dying ember that has been burning since the dawn of creation. Because they are so old, they are metal poor. They contain almost no iron, calcium, or oxygen, the heavy elements that are forged in supernovae and needed to build planets. It is unlikely that life exists here. There are no rocky worlds to stand on, only balls of pure hydrogen and helium. But the environment is breathtaking. The stars in a globular cluster are packed 10,000 times more densely than in our neighborhood. If you lived on a planet inside one of these clusters, you would never know night. The sky would be ablaze with thousands of stars brighter than Venus, casting a perpetual, omnidirectional twilight. These clusters do not orbit in the flat plane of the disk. They plunge through the galaxy at wild, plunging angles, diving through the spiral arms and shooting back out into the halo like comets. They are the wandering nomads of the galaxy, the survivors of the chaotic era of formation. There are about 150 of them orbiting the Milky Way, silent witnesses to our history. But not all galaxies are lucky enough to have such a structured, elegant design as ours. Not every galaxy gets to be a beautiful spiral with a halo of jewels. Some galaxies are simply massive, shapeless blobs of light. They are the giants of the cosmos, but they are dead giants. We turn our telescope away from home to look at the elliptical galaxies. We are about to visit the retirement homes of the universe. We leave the vibrant blue and yellow tapestry of the Milky Way and travel deep into the intergalactic void. We are looking for the heavyweights of the cosmos. We find them in the form of elliptical galaxies. If a spiral galaxy is a complex, bustling city with distinct neighborhoods, an elliptical galaxy is a monolith. They are massive, featureless blobs of light. They have no spiral arms, no flat disk, and no central bulge. They look like giant, glowing footballs or spheres, fading gently from a bright center to a diffuse edge. But the most striking difference is the color. There is no blue here. The entire galaxy glows with a uniform, reddish-gold hue. This color is the color of age. Elliptical galaxies are the retirement homes of the universe. They are populated almost exclusively by old, low-mass stars, red giants and red dwarfs that have been burning for billions of years. The blue stars died out long ago, and they were never replaced. This is because elliptical galaxies are dead in the biological sense of the cosmos. They have run out of gas. They have no cold hydrogen clouds, no dust lanes, and no nebulae. Without this raw material, star formation has completely ceased. There are no stellar nurseries here, no newborn suns screaming into existence. There is only the quiet, steady burning of the ancients, slowly fading away into the dark. But do not mistake this stillness for weakness. Elliptical galaxies are the largest structures in the universe. The biggest ones, known as CD galaxies, sit at the centers of massive galaxy clusters, and they are monsters. One such giant, IC 1101, is 6 million light-years wide, 60 times larger than the Milky Way. It contains 100 trillion stars. If you lived inside it, the night sky would be a wall of light, thousands of times brighter than our own. But how do they get so big? How does a galaxy become a giant, dead blob? The answer is violence. Elliptical galaxies are not born, they are made. They are the wreckage of 1,000 crashes. They are formed when two spiral galaxies collide and merge, their delicate arms smashed together and their gas stripped away, leaving only a chaotic ball of old stars. They are the final state of galactic evolution, the graveyard where spirals go to rest. But not every galaxy is a grand spiral or a massive elliptical. Scattered between the giants are the misfits. They are the small, the chaotic, and the shapeless. They are the leftovers of creation. We transition now from the order of the giants to the anarchy of the dwarfs. We are about to meet the agents of chaos. We have seen the elegant spirals turning like clockwork. We have seen the massive ellipticals sleeping in their golden age. But the universe is not always neat, and it is not always orderly. Scattered among the giants, like debris left over from a construction site, are the irregular galaxies. They are the misfits of the cosmos. They have no spiral arms, no central nucleus, and no defined axis of rotation. They are chaotic, shapeless clouds of starlight, gas, and dust, looking like splotches of paint thrown against a black canvas. They are usually small dwarf galaxies containing only a few billion stars compared to the Milky Way's hundreds of billions. But despite their size, they are often the most active places in the universe. Because they are rich in gas and dust, they are often in the grip of a violent starburst. They are churning out new stars at a rate that puts the Milky Way to shame, their interiors lighting up with the fierce blue glow of newborn suns. But why are they so messy? Why didn't they form into nice, neat disks? The answer is usually gravity. Many irregular galaxies were once normal spirals or ellipticals that got too close to a bully. They grazed the edge of a larger galaxy, and the massive gravitational tides ripped them apart, twisting their structure and scrambling their orbits. We can see this happening in our own backyard. If you are in the southern hemisphere, you can look up and see two glowing clouds detached from the Milky Way. These are the large and small Magellanic Clouds. They are irregular dwarf galaxies that orbit the Milky Way, and they are being slowly torn to pieces by our gravity. They are the victims of a galactic bullying session, their gas being stripped away to feed our own disk. But irregulars are not just victims, they are also the ancestors. In the early universe, before the great spirals formed, everything was irregular. The cosmos was filled with small, chaotic blobs of gas and light. Over billions of years, these blobs crashed into each other, merging and clumping together to build the massive structures we see today. The irregular galaxies we see now are the leftovers. They are the few remaining building blocks that haven't yet been snapped into a larger structure. But their time is coming. Gravity is patient, and it is hungry. The destiny of almost every small galaxy is to be eaten by a large one. We are now witnessing the dark side of galactic evolution. We are moving from the chaotic leftovers to the process of consumption. We are about to witness the galactic cannibal. We tend to think of the Milky Way as a stable, peaceful home. But if we look closely at the outer halo, we find evidence of a violent history. The galaxy is not just an island, it is an empire. And like all empires, it was built on conquest. We are currently witnessing a crime scene. Wrapping around the Milky Way, like ribbons wrapped around a pole, are long, thin streams of stars. These are the stellar streams. They are not natural formations of the galaxy, they are the entrails of victims. They are the remains of dwarf galaxies that ventured too close to our borders and were captured by our gravity. As a small galaxy falls toward the Milky Way, it does not simply crash. It is stretched. The gravity on the side closest to us is stronger than the gravity on the far side. This tidal force rips the dwarf galaxy apart, unspooling it like a ball of yarn. The stars are strung out into a long line, trailing behind the core as it spirals inward to its doom. One of the most famous examples is the Sagittarius dwarf spheroidal galaxy. It is currently crashing through the other side of the Milky Way, invisible to the naked eye because it is hidden behind the dust of our own disk. But our telescopes reveal the truth. It has been smashed. It has lost 90% of its original mass. Its stars are being stripped away to join our halo, and its gas is being siphoned off to fuel our disk. The Milky Way is eating it alive. This process is called accretion, and it is the primary way that large galaxies grow. We do not just form from gas, we steal mass from our neighbors. We absorb their stars, their history, and their dark matter, adding it to our own bulk. The Milky Way has likely consumed a dozen small galaxies in its lifetime. Every time you look up at the night sky, you are likely seeing a few stars that were not born here. They are immigrants, refugees from a dead galaxy that was swallowed billions of years ago. But while this slow consumption of dwarfs is a daily snack for a giant like the Milky Way, it is nothing compared to the main event. Sometimes the victim is not a dwarf. Sometimes the victim is an equal. What happens when two giants meet in the dark? What happens when a galaxy collides with another galaxy of the same size? We are about to witness the most spectacular, slow-motion disaster in nature. We transition now from the snack to the crash. We are about to witness the slow crash. When we hear the word collision, we imagine metal crunching, glass shattering, and an immediate, violent stop. But in the cosmos, a collision is a ghost story. It is an event that takes hundreds of millions of years to unfold, playing out in absolute silence. We watch two massive spiral galaxies approaching each other. Gravity has locked them in a fatal embrace. They accelerate, falling toward a common center of gravity at millions of kilometers per hour. The impact is inevitable. But when they finally meet, there is no bang. There is no explosion. The two galaxies simply pass through each other. How is this possible? The answer returns to the scale we established at the beginning. Galaxies are almost entirely empty space. Remember the analogy. If stars were grains of sand, they would be miles apart. So, when two galaxies collide, the chances of two individual stars physically hitting each other are effectively zero. It is like two swarms of bees flying through each other. The swarms merge, but the individual bees never touch. The stars of Galaxy A glide harmlessly past the stars of Galaxy B, missing each other by light years. But while the stars miss, the gravity does not. Gravity acts like a massive tidal wave. As the galaxies pass through each other, the gravitational field of Galaxy A grabs the stars of Galaxy B and yanks them violently off course. The delicate spiral arms are shattered. Stars are flung out into deep space, ripped from their orbits by the passing mass. This creates tidal tails, long, beautiful streamers of stars that stretch out for thousands of light years, looking like antennas reaching into the void. While the stars survive, the gas does not. Unlike the stars, the giant clouds of hydrogen gas are large and diffuse. They cannot miss each other. They slam together head-on. The shock wave is catastrophic. Millions of light years of gas are compressed in an instant. This triggers a starburst of unimaginable proportions. The collision zone lights up with the birth of billions of new stars, turning the wreckage into a blazing fireworks display of blue and white light. Supernovae go off like popcorn, exploding by the thousands. The black holes in the centers of the galaxies wake up, fed by the sudden influx of gas, and begin to blast jets of radiation into the cosmos. The two galaxies fly apart, wounded and distorted, but gravity will not let them escape. They slow down, stop, and fall back together for a second pass. Then a third. They swing around each other like pendulums, losing energy, the distance between them shrinking with every pass. Eventually, the dance ends. The two distinct shapes merge into one chaotic blob. The spiral structure is gone forever. The gas is used up. The blue light fades. What is left is a single massive ball of old red stars. A new elliptical galaxy has been born from the ashes of the crash. This is not just a theoretical scenario happening in deep space. It is a prophecy. We look up at the constellation Andromeda and we see a small patch of light. It is the Andromeda Galaxy, and it is getting bigger. It is falling toward us at 110 kilometers per second. The crash is coming. We transition now from the general theory to the specific fate of our own home. We are about to witness the marriage of giants. We stand on the surface of the Earth 4 billion years from now. The sun has grown brighter, scorching the planet, but let us assume we are watching from a safe vantage point. We look up at the night sky. It is no longer the calm, familiar scattering of stars we know today. It is dominated by a wall of light. The Andromeda Galaxy has arrived. It fills the entire horizon, a swirling majesty of 1 trillion stars that is so close you feel you could almost reach up and touch the spiral arms. It is a breathtaking, terrifying sight. The collision between the Milky Way and Andromeda is no longer a prediction, it is happening. As gravity takes hold, the sky begins to twist. The band of the Milky Way, our own home, begins to warp and buckle under the tidal pull of the invader. Andromeda too is being stretched, its beautiful disk distorted into a giant shape. Great streams of gas and stars are being ripped out of both galaxies, flung across the sky like glowing confetti. This is the first pass. The two giants swing past each other, missing a direct hit, but the gravity acts as a brake. They drift apart, turning around slowly in the deep void, their shapes ruined, their structures chaotic. Then they fall back together. 7 billion years from now, the final merger occurs. The cores of the two galaxies, the two supermassive black holes, spiral inward. They find each other in the chaos, circling faster and faster until they merge in a burst of gravitational waves that shakes the fabric of space-time. The gas clouds collide, triggering the last, greatest firework display in the history of our local group. But then, the lights go out. The gas is used up. The blue stars die. The dust settles. The two spirals are gone. In their place stands a single, massive, elliptical galaxy. Scientists have already named this future giant Milkomeda. It will be a huge, red, spherical blob, quiet and still. And what of the Sun? Surprisingly, our solar system will likely survive this violence. Because space is so empty, the chances of the Sun colliding with another star are tiny. We will likely be flung out into the outer halo of the new galaxy, ending up much further from the center than we are now. Our descendants, if they exist, will look up at a sky that is strangely empty. The band of the Milky Way will be gone. The spiral arms will be a memory. They will live in a sky of uniform, ancient starlight, residing in the retirement home of the cosmos. But while the galaxy feels vast to us, seemingly the whole universe, it is actually just a speck. Even Milkomeda will be just one dot in a much larger structure, because galaxies do not float randomly in space. They are connected. There is an architecture to the nothingness. We are about to zoom out to a scale that makes a galaxy look like a pixel. We are about to see the scaffolding of the universe. We transition now from the island to the web. We are about to reveal the invisible scaffold. We have talked about gravity as the glue of the universe. We have said that gravity holds the stars in their orbits and binds the galaxies together. But there is a problem. A massive, glaring problem that astronomers discovered in the 1970s. When we look at a spiral galaxy like the Milky Way, we can calculate how much mass is there. We count the stars, we measure the gas, and we add up the dust. We put it all on a scale, and we get a number. Then, we calculate how much gravity that mass should produce. According to the laws of Isaac Newton and Albert Einstein, that gravity should determine how fast the galaxy spins. Just like the solar system, objects near the center should orbit quickly, and objects at the edge far from the source of gravity should orbit slowly. Pluto moves much slower than Mercury. So, the stars at the edge of the galaxy should be leisurely drifting. But when the astronomer Vera Rubin measured the speeds of these outer stars, she found something impossible. They were moving just as fast as the inner stars. In fact, they were moving so fast that they should have been flung out into deep space millions of years ago. The visible gravity of the galaxy is not strong enough to hold them. It is like watching a merry-go-round spinning at 100 miles an hour, but the children are not flying off. They are sticking to the ride as if held by invisible ropes. There was only one conclusion. There must be more matter there. A lot more. To hold these fast-moving stars in place, the galaxy needs to be 5 times heavier than it looks. We call this missing mass dark matter. But the name is misleading. It is not actually dark. Dark implies a shadow or a black paint that absorbs light. But this substance does not interact with light at all. It is invisible. Light passes right through it like it isn't there. It doesn't reflect, it doesn't emit, and it doesn't absorb. We cannot see it, touch it, or bottle it. We only know it exists because of its gravity. It is the ghost in the room that is pushing the furniture around. And it is everywhere. The Milky Way is not just a disk of stars, that is just the visible tip of the iceberg. Our galaxy is embedded in a massive spherical cloud of dark matter that extends far beyond the halo. This invisible cloud is the true galaxy. The stars and gas are just a shimmering decoration, a dusting of glitter trapped in the center of a much larger, invisible well. This changes our entire understanding of the architecture of the universe. We used to think that galaxies were the structures. Now we know that galaxies are just the lights on the Christmas tree. The tree itself, the structure that holds everything up, is made of dark matter. It is the invisible scaffold. In the early universe, it was dark matter that clumped together first. It formed the gravitational potholes that the normal gas fell into. Without dark matter, the gas would never have collapsed to form stars. Without dark matter, the galaxies would fly apart. Without dark matter, we would not exist. It is the silent, unseen guardian that holds the cosmos together. But this guardian does not just hold individual galaxies. It connects them. If we could put on dark matter goggles and look out into the deep universe, we would see that the galaxies are not isolated islands. They are clustered together in great swarms. We are about to zoom out to the neighborhood level. We are about to see the hive. We transition now from the invisible halo to the visible swarm. We are about to enter the clusters. We are leaving the suburbs. Our own galaxy, the Milky Way, is a member of a small, quiet neighborhood known as the local group. It is a modest cul-de-sac containing just 3 main spirals: us, Andromeda, and Triangulum, along with about 50 tiny dwarf galaxies. It is a peaceful, rural existence. But if we travel 50 million light-years away toward the constellation of Virgo, we hit the metropolis. We encounter the Virgo cluster. This is not a family, it is a hive. It is a chaotic swarm of 2,000 galaxies, all bound together by a single, terrifyingly strong gravitational well. As we approach, the view is dizzying. Everywhere we look, there are galaxies. They are buzzing around the center of the cluster at incredible speeds, whipping past each other like gnats in a storm. And in the center of this swarm sits the monster we mentioned earlier, M87. It is a supergiant elliptical galaxy, a bloated spider sitting at the center of the web, having grown fat by eating its neighbors. But the most dangerous thing about a cluster is not the galaxies themselves. It is the space between them. In the local group, the space between the Milky Way and Andromeda is a true vacuum, cold, dark, and empty. But in the Virgo cluster, the space is not empty. It is filled with a superheated fog known as the intracluster medium. This is gas that has been ripped out of the galaxies during their violent interactions, and it is incredibly hot, millions of degrees. It glows brightly in X-ray telescopes, outshining the galaxies themselves. For a galaxy, flying through this gas is a death sentence. As a spiral galaxy falls into the cluster, it plows through this thick, hot wind. The wind acts like a blowtorch. It physically blows the cool, fragile hydrogen gas out of the galaxy, stripping it clean. This process has a violent name: Raman pressure stripping. We can see galaxies in the Virgo cluster that are currently undergoing this torture. They look like jellyfish. They have long tentacles of blue gas trailing behind them, stripped away by the headwinds of the cluster. Once the gas is gone, the galaxy dies. It can no longer make new stars. It turns red and fades, becoming one of the thousands of silent, zombie ellipticals that populate the cluster. This is why cities are dangerous. The cluster is a graveyard for spirals, a place where the delicate architecture of star formation is destroyed by the sheer density of the environment. But even the Virgo cluster, with its thousands of members, is just a single knot. It is just one intersection in a much larger road network. If we pull back even further, zooming out until the entire cluster becomes a single dot of light, we begin to see the true shape of the universe. We see that the clusters are not scattered randomly. They are lined up. They are strung like pearls on a necklace. We are about to reveal the largest pattern in nature. We are about to see the threads of night. We transition now from the cluster to the filament. We are entering the cosmic web. We have arrived at the ultimate vantage point. We are looking at the universe on a scale of billions of light years. From this distance, individual stars are invisible. Individual galaxies are invisible. Even the massive clusters, with their thousands of galaxies, appear only as bright specks of light. But when we look at the arrangement of these specks, we see a pattern that stops the breath. The universe is not a random cloud. It is a web. It looks exactly like the neural network of a brain or the intricate fibers of a sponge. This is the cosmic web. It is the largest structure in existence, a vast, three-dimensional scaffolding that fills the entire observable universe. The strands of this web are called filaments. These are long, thin rivers of dark matter that stretch across hundreds of millions of light years, connecting the galaxy clusters like highways between cities. Gravity flows along these roads. Gas and dwarf galaxies fall onto the filaments and slide along them, funneling down into the massive clusters that sit at the intersections. If you could see the dark matter, it would look like a glowing spider web, with the bright clusters acting as the dewdrops caught in the silk. The scale is terrifying. We see structures like the Sloan Great Wall, a single wall of galaxies 1.4 billion light-years long. We see the Laniakea supercluster, our own home address. Laniakea means immeasurable heaven in Hawaiian, and it is a fitting name. It is a flowing watershed of 100,000 galaxies, all sliding toward a mysterious gravitational point called the Great Attractor. But Laniakea is just one thread in the tapestry. There are billions of them, weaving together to form a structure that looks surprisingly biological. Why does the universe look like a sponge? Because of the beginning. In the first nanoseconds after the Big Bang, the universe was almost perfectly smooth. But there were tiny, quantum fluctuations, microscopic ripples in the density of matter. As the universe expanded, these tiny ripples were stretched out. Gravity amplified them. The slightly denser areas pulled in more matter, growing into filaments. The slightly emptier areas lost matter, becoming emptier. Over 13.8 billion years, gravity sculpted the primordial soup into the intricate lattice we see today. It is a frozen record of the creation event. But a web is defined not just by its threads, but by the holes between them. If the filaments are the cities and the roads, what is the rest of the map? It is nothing. It is a desert of unimaginable proportions. We are about to look into the gaps. We transition now from the structure to the absence. We are entering the great voids. If the filaments are the bustling highways of the universe, the voids are the wilderness. They are the vast, spherical bubbles of emptiness that sit between the threads of the web. Imagine a block of Swiss cheese. The cheese represents the filaments and clusters where the galaxies live. The holes are the voids. And just like in the cheese, the holes take up most of the volume. 80% of the universe is empty space. We are currently floating toward the Bortes Void, one of the largest deserts known to man. It is a perfect sphere of nothingness, nearly 300 million light-years across. If the Milky Way were in the center of the Bortes Void, we would not have known that other galaxies existed until the invention of telescopes in the 1960s. The night sky would be completely black, devoid of any neighbors. For a long time, astronomers thought these voids were completely empty. But as our instruments improved, we found the hermits. Drifting alone in the eternal dark, millions of light years from the nearest filament are the void galaxies. They are the loneliest objects in creation. They have never collided with another galaxy. They have never eaten a dwarf. They have never felt the hot wind of a cluster. Because they are so isolated, they are pristine. They are time capsules from the early universe, evolving in a vacuum with no interference. Life on a planet in a void galaxy would be incredibly lonely. Astronomers there would look out and see nothing. No Andromeda, no Virgo cluster, no Great Wall. Just an endless black abyss extending forever in every direction. They would believe their galaxy was the only thing in existence. But in a strange twist of fate, these voids are not just empty space. They are growing. They are expanding faster than the rest of the universe, pushing the filaments apart, squeezing the galaxies into tighter and tighter walls. They are the engines of the end, because there is a force lurking in the nothingness, a force that is stronger than gravity, a force that is tearing the web apart. We have reached the end of the map. We are about to look into the future. We transition now from the geometry of space to the death of structure. We are entering the tier. We have spent this journey marveling at the structure of the universe. We have seen how gravity acts as the great architect, pulling dust into stars, stars into galaxies, and galaxies into the magnificent filaments of the cosmic web. It seems like a story of connection. But there is a twist in the final chapter. For decades, astronomers believed that gravity would eventually win. They thought the expansion of the universe started by the Big Bang would eventually slow down, halted by the gravitational pull of all this mass. They thought the web would tighten, pulling the clusters back together for a final big crunch. But in the late 1990s, we looked at distant supernovae and we found the exact opposite. The expansion is not slowing down. It is speeding up. There is a mysterious energy pushing the universe apart, acting as an anti-gravity force that permeates every inch of empty space. We call it dark energy, and it is relentless. While gravity tries to hold the web together, dark energy is stretching the canvas. Right now, gravity is strong enough to hold the tight clusters like Virgo and our local group together. But on the grand scale, the web is being torn. The filaments are stretching. The voids are expanding. The distance between the galaxy clusters is growing wider every second. If we fast forward the clock, we see the tragic destiny of the architecture we just explored. In 100 billion years, the other clusters will be pushed away from us faster than the speed of light. The light from the Virgo cluster will no longer be able to reach us. It will redshift, fade into infrared, then radio, and then silence. The cosmic web will disappear from view. The filaments will snap. Future astronomers living in Milkomeda will look out and see a universe that is truly empty. They will have no evidence of the Big Bang. They will have no evidence of the expansion. They will have no evidence of other galaxies. They will think that their galaxy is the entire universe, a lonely island of stars in an infinite, static void. History will be erased by the horizon. We are living in a privileged time. We are living in the golden age of astronomy. We are the only generation that will ever see the universe in its full glory, connected, vibrant, and visible. We can see the past, and we can predict the future. We can see the web before it tears. As we float back down toward the spiral arm of the Milky Way, returning to our tiny blue planet, we should not feel insignificant. We should feel grateful. We are the witnesses. We are the eyes of the universe, open for a brief, shining moment before the lights go out. The great spiral turns. The black hole sleeps. The web stretches in the dark. And we are here to see it all. The observation is complete.